Far beyond the shimmering edge of our solar system, past the icy realm of the Oort cloud, a quiet whisper of light has caught the attention of humankind. Detected by the James Webb Space Telescope, this faint but persistent glow appears to originate from an object located approximately 7 trillion miles away from Earth, just over 1 light-year into the interstellar void. At that staggering distance, sunlight fades into obscurity and temperatures plunge to near absolute zero. And yet, in this cold and desolate expanse, something is shining. This light is not a flickering comet or a distant star. It is steady. It is structured. It bears a spectral signature more consistent with artificial illumination than with any known natural process. No pulsations, no random scattering. Just a clean, persistent emission in the infrared range. It is the kind of glow you might expect to see above a city skyline at night, not from a place where no planet, no sun, and no known civilization should exist. For scientists and dreamers alike, it is a puzzle that defies everything we thought we knew about the boundaries of life and light. In this video, we will dive deep into what this discovery could mean, not only from a scientific perspective, but also from a philosophical one. Could this be the first sign of intelligent life beyond our solar system? A rogue spacecraft, a drifting city, or something even stranger? As we journey together through the evidence, the theories, and the implications, keep one question in mind. What does it mean when the dark is not truly dark anymore? The cosmos may have just whispered back, and what it said changes everything. Every great discovery in science begins not with certainty, but with doubt. The James Webb Space Telescope was not searching for aliens or anomalies when it recorded the signal. Instead, it was performing a scheduled deep-field survey along the outskirts of the Oort cloud, a vast, spherical shell of icy bodies that marks the outermost boundary of our solar system. This region is known for being quiet, distant, and cold. Scientists were expecting subtle thermal readings, perhaps a glimpse of a drifting comet or scattered dust reflecting faint solar radiation. But buried within the expected data was a detail that did not match the rest, a warm, organized glow in the infrared spectrum, something that simply should not be there. Infrared light is invisible to the naked eye, but it tells a powerful story about heat, energy, and composition. The James Webb Space Telescope was specifically designed to detect this kind of radiation, especially the faint warmth of objects that lie far beyond the reach of visible light. In this case, the signal was not chaotic or sporadic, as one would expect from thermal echoes of rock or ice. Instead, the pattern was regular, structured, and constant. The intensity of the glow was modest, but its stability was striking. No flickering, no fading. Just a low, unwavering pulse, like the hum of a machine running in the dark. The team at the Space Telescope Science Institute in Baltimore initially responded with caution. Any claim that hints at artificiality must be handled with extreme care. The scientists reviewed internal instrument logs, double-checked calibration data, and ran simulations to rule out everything from sensor malfunctions to interference from known celestial bodies. After exhausting all mundane explanations, they did the only responsible thing. They pointed the telescope back toward the same coordinates and waited. When the second scan returned, it confirmed the first, and then came a third and a fourth. Each time, the light appeared, steady and unchanged. Something persistent, something real. Further analysis revealed another curious detail. The light did not seem to come from a planet orbiting a star. It was not gravitationally tethered to any stellar system. Instead, the object appeared to be moving slowly, independently, through interstellar space. This suggests one of two things. Either it is a rogue planet, ejected from its solar home, or it is something built, a structure perhaps, floating freely between stars. In either case, it would have to generate its own energy, survive the cold vacuum, and resist the slow bombardment of cosmic radiation. For the light to be as steady as it is, the source would need to be both durable and self-sustaining. By this stage, the nature of the discovery had outgrown the confines of any single team or institution. The data was quietly shared with other observatories, both on Earth and in space. Using adaptive optics and long-range spectroscopy, multiple instruments attempted to validate what the James Webb Space Telescope had seen. The results were consistent. Different eyes, different lenses, same glow. In the silence of deep space, something was shining in a way that nature almost never does. It was geometrically aligned, thermally balanced, and seemingly artificial. And so, with growing confidence and a measure of awe, the scientific community began to ask the question it had long been afraid to ask. What or who could be out there? Light in the cosmos is everywhere, but it rarely behaves with intention. Stars blaze and die, planets reflect and shimmer, and nebulae pulse with the chaotic rhythms of gravity and fusion. Yet the light detected by the James Webb Space Telescope was different. It was not scattered, irregular, or variable. It did not flicker as an object rotated, nor did it swell and dim like a dying star. Instead, it was fixed, steady in intensity, consistent in shape, and persistent in presence. Its signature suggested not the wild hand of nature, but the careful geometry of engineering. More revealing than its steadiness was the spectrum of the light. When scientists analyzed the wavelengths, they found that it clustered in the mid-infrared range, a region typically associated with low-temperature emissions, such as those produced by machinery, artificial lighting, or residual heat from energy use. This range of light is not something that a cold asteroid or frozen dust cloud would emit on its own. It matches instead the glow of human cities as seen from orbit, the signature of ordered systems generating warmth and light in deliberate patterns. In short, it looked remarkably like illumination, manufactured, managed, and maintained. Even more intriguing was the pattern of the emission. The light did not form a sphere, nor did it spread randomly. It appeared in a grid, linear, structured, and uniform, as if placed or designed. This is not how natural objects behave in space. Gas giants might emit in bands, stars in rays, and nebulae in clouds. But this was precise. The energy map looked artificial, resembling the spatial layout of an urban landscape, as if towers or nodes were radiating energy in a coherent, purposeful way. The comparison to Earth's cities, while imperfect, was impossible to ignore. No known natural process can explain this level of consistency and organization without invoking life, intelligent life. The light's endurance suggests a power source that is stable and long-lasting. Yet there is no nearby star to provide solar energy. That leaves only internal generation, nuclear fusion, geothermal heat, or some advanced energy system that humanity has not yet conceived. The structure, if it is a structure, must also be insulated against the brutal cold of deep space, protected from radiation, and self-regulating. It must, in other words, be engineered for survival and continuity. This leads to the most profound realization of all. If this light is truly artificial, then it is not merely a curiosity, it is a statement. It means that somewhere, somehow, intelligence has created a system capable of sustaining activity in a region of space once thought to be utterly dead. It may be inhabited or abandoned, ancient or newly built, but it exists, and by existing, it rewrites the boundaries of what we consider possible. In the vacuum between stars, far from any warmth or world, there is light, and light, in every culture known to humankind, has always meant life, presence, and purpose. When confronted with something beyond understanding, the human mind does what it has always done. It begins to imagine. The light detected by the James Webb Space Telescope is no longer debated as a trick of instrumentation. It is real. But what could it be? Among the scientific community, theories have blossomed like stars in the night sky, each one reaching into the unknown to make sense of the impossible. The most conservative explanation suggests that we are witnessing a massive rogue planet, an orphaned world ejected from its native solar system, drifting endlessly through the interstellar void, yet somehow still warm and active. Perhaps deep within its crust, radioactive decay or internal fusion powers subsurface oceans or artificial constructs, giving rise to the eerie glow we now observe. Another hypothesis, bolder and more provocative, envisions a kind of interstellar ark, a generation ship. This would be a colossal vessel designed to carry life across unimaginable distances, possibly over many centuries or even millennia. Such a ship might house entire ecosystems, artificial gravity systems, and internal light sources designed to mimic the rhythms of planetary life. The steady illumination captured by JWST could be nothing more than functional lighting, the glow of cities enclosed within a hull, maintaining life in a metal womb as it travels between stars. The idea may seem like science fiction, but the light aligns all too well with what we might expect from such a construct. Some theorists point toward the possibility of a technological remnant, what they call a Dyson fragment. A Dyson structure, in theory, is a megastructure built to harness the full energy output of a star. It could take the form of a sphere, a swarm, or even mobile collectors. A fragment of such a construct, either intentionally separated or accidentally ejected, could remain active for untold ages, drifting silently while still running on residual or stored energy. If it were equipped with automated systems, maintenance drones, internal sensors, light regulators, it might continue to glow, even in isolation. What we are seeing might not be a habitat at all, but the ghost of a far grander machine. And then there is the most thrilling and most controversial possibility that this is a settlement, a city, a deliberate outpost constructed not on a planet, but in the darkness between stars. If that is true, then we are not looking at a remnant or a relic, but an active society, living, working, and evolving beyond the reach of any sun. Such a civilization would possess technologies beyond our current comprehension: self-sustaining energy production, long-term environmental control, and architecture capable of enduring cosmic hazards. But beyond the engineering, it implies something more: intention. A desire to build not where it is easy, but where it is meaningful. To place light, not in convenience, but in defiance of the dark. Each of these theories carries weight, and each raises new questions. If it is a ship, who launched it? If it is a remnant, what destroyed the whole? If it is a city, why here, in the middle of nowhere? Could it be a relay station, a beacon, a monument, or something we do not yet have the language to describe? In every version, one truth remains: this light is not random. It exists by choice, by force, or by memory. It burns in a place where nothing should burn, and that alone changes everything. Whether artificial planet, drifting cathedral, or lost ark, the light speaks, and we, for the first time, are listening. The discovery of a steady, structured light source in interstellar space has shattered a boundary long believed unbreakable. For centuries, the search for life beyond Earth has been confined to the comfortable logic of habitability. The notion that life, especially intelligent life, requires a planet orbiting a sun with just the right temperature, atmosphere, and resources. This model, called the Goldilocks zone, has defined where telescopes point and how missions are prioritized. But the light, silent and persistent in a region utterly devoid of stars or warmth, forces a radical rethinking. If something or someone has built and maintained an illuminated presence in such a hostile environment, then life may not be where we expected, and it may not look like anything we imagined. This revelation expands the very definition of habitability. No longer is it enough to search for rocky planets in the orbits of yellow suns. We must now consider that life might exist in artificial environments, crafted and sustained far from natural ecosystems. In this light, the idea of a biosphere becomes untethered from planetary surfaces. Perhaps intelligence, once it reaches a certain level of technological mastery, no longer requires a planetary home at all. It migrates into space, building what it needs, where it needs it, drawing energy from fusion, gravitational compression, or even unknown mechanisms beyond our physics. The light challenges the notion that stars are essential to civilization. It whispers that life may adapt not by bending to nature, but by overcoming it entirely. This leads inevitably to questions of scale and intention. The structure emitting the light, whatever it may be, is not just active, it is stable, and stability in deep space is not easy. It suggests an incredible degree of engineering, foresight, and energy control, shielding against cosmic radiation, insulating from thermal extremes, generating light not as a side effect, but as a maintained system. All of this implies purpose. So what then is that purpose? Is the light a beacon, a navigational marker, a remnant of something long gone, still glowing through inertia? Or is it functional, a habitat, a vessel, a community silently carrying on, indifferent to whether anyone ever sees them? Humanity is unprepared for the philosophical weight of these possibilities. Our entire scientific framework, brilliant as it is built upon models that assume life as we know it. But now we are confronted with a model of life as we do not know it. Life that creates its own warmth, sustains itself in isolation, and signals presence not with words, but with illumination. This forces us to confront the question, what does it mean for something to be alive? Is it metabolism, communication, consciousness? Or is it, as the light seems to suggest, the mere act of continuing, of insisting on being seen across impossible distances? There is also the question of time. Light takes over a year to travel from that region to Earth. That means what we are seeing is not the present, but the past, a ghost of a moment already gone. The structure could have changed, moved, dimmed, or disappeared entirely by now. But perhaps it has not. Perhaps it is still there, still glowing, as it has for decades or centuries. If so, then we may be looking not at a transient anomaly, but at something built for permanence. That alone is staggering. Humanity rarely builds for 1,000 years. Yet this might be just that, a long-lived artifact, defying decay, speaking across time as well as space. And so, the questions multiply. If we are seeing the light, have others seen us? If someone has mastered the art of life between stars, have they also mastered the art of observation? Could they be watching Earth, not as conquerors or gods, but as fellow travelers? And if they are aware of us, what might they think? That we are noisy, unstable, bright and brief? Or that we too are trying? That we too are learning to shine in the dark? The light does not answer. It does not comfort or threaten, but it changes everything. It moves the boundary of where we thought life could go. And now, we must decide how far we are willing to follow it. The discovery of a possible artificial light source drifting through interstellar space has not only sparked awe, it has restructured the way science itself must proceed. In laboratories, observatories, and academic institutions around the world, priorities are shifting. Data once ignored or dismissed as noise is now being reanalyzed under a new lens. Entire archives of telescope recordings are being reviewed for subtle thermal anomalies or structured emissions. It is no longer sufficient to search for Earth-like planets in sunlit zones. Instead, attention is expanding to include the quiet, cold, and overlooked spaces between the stars. These voids, once deemed lifeless, may now contain the most profound evidence of intelligence in the cosmos. International space agencies, including NASA, the European Space Agency, and the Japan Aerospace Exploration Agency, are reassessing mission roadmaps in light of this anomaly. Future telescope designs are being reconsidered, incorporating enhanced infrared sensitivity and longer exposure capabilities. Projects that had once focused on stellar mapping or exoplanet surveys are now being tailored to detect artificial-looking energy patterns, linear thermal grids, persistent low-heat signatures, and geometric distributions of light. The Nancy Grace Roman Space Telescope, still in development, may now be outfitted with instruments designed not only to observe galaxies, but to hunt for the unexpected, the deliberate amidst the random. On the ground, global observatories are coordinating like never before. High-altitude facilities in Chile, Hawaii, and the Canary Islands are collaborating to triangulate and refine the signal's origin. Universities are forming multidisciplinary think tanks, blending astrophysics, data science, artificial intelligence, and philosophy. This is no longer a problem for astronomers alone. It is a scientific moment that demands convergence. Engineers must ask how a structure could survive deep space. Linguists must consider how communication might occur across species. Biologists must reconsider what life means when it is sustained far from any natural biosphere. The search for extraterrestrial intelligence has evolved from fringe science into the center of human inquiry. Governments, too, are taking notice. High-level meetings, once reserved for planetary defense and orbital security, now include briefings on the light source. Classified research initiatives have reportedly begun, exploring both the potential risks and opportunities of such a discovery. For the first time, global powers are facing the possibility that humanity may not be the most advanced intelligence within observational reach. And while this realization is humbling, it is also unifying. Quiet discussions have begun around the need for a planetary scientific council, a collaborative body that can set ethical frameworks, share data transparently, and coordinate our response to potential contact scenarios. The impact also extends into security and diplomacy. If the object is a probe, could it be monitoring us? If it is a settlement, does it pose a threat or a potential ally? These questions, once confined to speculative fiction, now hold strategic weight. Nations that were once competitors in the space race are beginning to understand that the next era of exploration may not be national. It may need to be planetary. Resources are being allocated for research into long-range space propulsion, deep space communication protocols, and theoretical models of interstellar ethics. A shared unknown, it seems, may finally forge shared intent. At the heart of this global pivot is a single, inescapable truth. Science has been forced to expand its imagination. The cosmos is no longer a vast silence dotted by stars. It may be a landscape of intentionality, of structures and signals waiting to be seen. The James Webb Space Telescope has opened a door not just to distant light, but to a future where observation and responsibility walk hand in hand. As instruments turn toward the dark with new focus, and as nations reorient toward cooperation, the question is no longer whether we are ready to explore the stars. The question is whether we are ready to be noticed. If the light is a message, the first question must be, who is it for? The idea that we might not be alone has fascinated human beings for centuries. But fascination becomes urgency when a possible sign of intelligence shines clearly and persistently in the dark. Communication, once the domain of dreamers and theorists, now enters the realm of policy and practice. Yet the challenge is immense. The light source is located over 1 light-year from Earth. That means even the fastest possible message, traveling at the speed of light, would take more than a year to arrive. Any reply would take another year, assuming, of course, the receiver is watching, willing, and able to understand. But the true challenge is not distance, it is translation. How does one communicate with a civilization that may not share our biology, our culture, or even our perception of reality? Mathematics has long been proposed as the universal language, with simple primes and geometric patterns as the opening lines of a cosmic conversation. Yet what if the language is not numbers, but light itself? What if the grid of illumination we observe is not only a power signature, but also a syntax, a visual grammar conveying intention or identity? If so, our task is not just to listen, but to learn how to read what is already being shown. Several research teams are now working to analyze the fluctuations, however subtle, within the detected signal. Are there variations over time? Do certain points in the grid brighten or dim in regular cycles? Could these be bits in a code or pulses in a symbolic system? Artificial intelligence is being used to search for patterns, symmetry, and irregularities that might hint at complexity. Meanwhile, linguists and semioticians are being invited into astrophysical discussions, an unusual but necessary collaboration. After all, if the object is a beacon or an outpost, it may not speak in waves or words. It may speak in presence, in architecture, in constancy. There is another, more provocative possibility. They already know about us. For over a century, Earth has been leaking radio and television signals into space. These electromagnetic waves travel outward at light speed, and by now, a 1 light-year radius contains the earliest echoes of our broadcasts. A civilization capable of building a structure in interstellar space would almost certainly be able to detect those emissions. They may have heard us long before we saw them. The absence of any obvious response may not mean ignorance or disinterest. It could mean observation, patience, or perhaps even a moral or philosophical stance against interfering with emerging civilizations. This possibility has sparked debate across scientific, political, and ethical lines. Should we send a signal? If so, what should it say? And who should decide? Is it wise to announce our presence, or should we remain quiet, observing from afar? The lessons of Earth's own history caution us. Contact between unequal cultures often leads to disruption, or worse. And yet the curiosity is powerful. A single, simple message, crafted with care, encoded with mathematics or light, could be the first handshake across the stars. But it must be offered with humility, and with the full awareness that we may not understand the answer or even recognize it as such. Whatever form contact may take, be it visual, physical, or merely symbolic, it will challenge our very conception of language, perception, and intelligence. It may not come in a moment of fanfare, but in the slow recognition of a shared logic, a shared rhythm in the universe. And perhaps that is the point. Perhaps the act of trying, of reaching out despite uncertainty, is the beginning of what it means to be part of something greater. As the light continues to shine from its distant, unblinking position, it reminds us that communication is not always about words. Sometimes it is about being seen, and in that silent recognition, the conversation may have already begun. The light has spoken not only to scientists, but to the soul of humanity. In the weeks since the discovery became public, its echo has rippled far beyond laboratories and observatories. It has entered classrooms, churches, studios, and dining tables. Artists have begun to reimagine the cosmos. Musicians compose symphonies inspired by the silence between stars. Filmmakers and writers, long drawn to the mystery of the unknown, now find their fictions edging toward reality. In poetry and in podcasts, in graffiti and in digital canvases, the light is becoming something more than data. It is becoming myth, our first new myth of the interstellar age. Educators around the world are also adapting. Astronomy lessons now include discussions about engineered habitats and post-planetary civilizations. Students are no longer taught only about moons and meteorites, but about Dyson swarms, rogue worlds, and the philosophical meaning of artificial life beyond Earth. In ethics classes, children debate whether humanity should try to respond to the light. In physics, the boundaries of possibility are redrawn. In literature, the language of loneliness begins to give way to the language of connection. The cosmos, once a cold expanse, now feels like a stage on which someone else has already performed. Religious and spiritual communities are experiencing their own awakenings. For some, the light confirms a long-held belief that life is not unique to Earth and that creation stretches far beyond our sky. For others, it raises deep and difficult questions. What does it mean if we are not alone? Is the human story still central in a universe shared with other minds? Some theologians propose that intelligent life elsewhere may be part of a divine plan. Others suggest the possibility of spiritual diversity on a cosmic scale. Belief systems not born of Earth's soil, but forged in alien traditions. The discovery of artificial light may open new doors in faith, or it may challenge the locks. Socially, the light has become a catalyst for reflection. Online forums and town squares alike are filled with conversations once thought too speculative. People wonder aloud what it would be like to live in the void, to build homes that never see a sunrise, to raise children among stars rather than under them. Questions of identity begin to shift. If we are not alone, then what does it mean to be human? Are we a single tribe on a pale blue dot, or part of a wider family whose members we are only now beginning to discover? National pride still stirs, but it now shares space with something older and deeper, a shared curiosity, a shared awe. Even politics cannot remain untouched. Leaders, often preoccupied with borders and budgets, now face the profound truth that Earth may not be the only civilization in this galactic theater. Some see an opportunity for global unity, others see a reason for caution or even fear. But across ideologies, the conversation is beginning to change. The question is no longer whether space exploration is worth the cost, it is whether we can afford to ignore it. The light has ignited not just a cultural renaissance, but a shift in priorities. Space is no longer a backdrop. It is becoming a frontier of meaning, identity, and purpose. In the end, the most lasting impact may be the most personal. The next time someone looks up at the night sky, they may no longer see emptiness. They may see possibility. They may wonder if, on some distant vessel or structure, someone else is looking back. They may carry the knowledge that light, steady, silent, and impossibly far, exists where none was expected, and in that realization, they may feel less alone. The light does not speak our language, but it speaks to our condition. It tells us that we are not the only ones who build, who shine, who persist. It tells us that we are part of something larger. And perhaps that has been the message all along. For all the science the light may inspire, its most profound impact may be philosophical. Humanity has always looked to the stars and asked, are we alone? But this question was never just about biology. It was about identity. It was about meaning. If the light proves to be artificial, and therefore intentional, then it is the first real evidence that we are not the only thinking species in the universe. That alone reshapes centuries of human self-understanding. Our myths, our religions, our philosophies all have, to some degree, been written in the context of cosmic solitude. The light may erase that solitude with a single glow. Existentially, the implications are staggering. For generations, we have framed the universe as a cold expanse in which life is a rare accident, confined to a pale blue world. Now, we are forced to consider that intelligence might be common, or at least resilient, that life, far from being an exception, may be a feature of the cosmos itself. This demands a re-evaluation of what it means to exist. Are we a spark in the dark, or one voice in a larger chorus? If we are not the first, not the highest, not even the most enduring form of life, what then is the measure of human greatness? Some philosophers have begun to draw parallels between the light and the idea of a cosmic mirror. In this view, the discovery is not just about them, it is about us. How we respond to the unknown will define our maturity as a species. Will we react with fear or with wonder? Will we seek conquest or conversation? The presence of another intelligence asks not only what they are, but who we are. It is not simply a question of contact, it is a test of character, and perhaps it is an invitation to grow, to rise beyond conflict, to begin thinking on scales greater than nations or centuries. Spiritual questions, too, come into sharp focus. If the universe contains other minds, does it also contain other forms of consciousness, morality, or even enlightenment? Could a civilization that builds in the dark possess not only advanced technology, but a deeper wisdom, a philosophy of light unknown to us? Some theologians have begun to imagine that the structure may be more than functional. It could be sacred, not in the sense of temples or shrines, but in the sense that it represents continuity, perseverance, and meaning beyond material survival. In that context, the light becomes a symbol, not of dominance, but of endurance, a quiet flame in the void. There are even those who suggest the light may be a form of communication so advanced that it is spiritual in nature. Light not just as signal, but as presence. After all, many ancient traditions associate illumination with knowledge, divinity, or the soul. A civilization that chooses to shine in the loneliest regions of space may be expressing something fundamental about its values. It may be declaring that existence, even in isolation, has worth, that to illuminate, to persist, is itself an act of beauty. Whether by design or by accident, the light speaks to something deep and enduring in the human spirit. In the end, philosophy and spirituality converge on one central truth. The light changes the question. It is no longer, is there someone out there? But what do we do now that we know? Do we withdraw in fear or step forward in curiosity? Do we see the light as competition or as kinship. In the silence of space, a new voice has entered the dialogue, not with words, but with presence, and it falls to us to answer, not just with science, but with integrity. The cosmos has grown larger, stranger, and more beautiful. The light reminds us that even in the coldest, darkest places, there may still be meaning, there may still be purpose, and there may still be others who, like us, chose to shine. The light remains unchanged. It continues to shine, steady and silent, from across the void. It does not speak, it does not move, it does not explain itself. And yet, it has already transformed the way we see the universe. The discovery made by the James Webb Space Telescope is not simply a scientific anomaly. It is a turning point, a quiet revolution. In a cosmos once thought to be empty, we have found something that does not belong, something that does not behave like a comet or a star or a drifting rock, something that might just be the evidence of intelligence beyond our own. And so, we find ourselves on the edge of a new frontier, not just of space, but of imagination. The questions are no longer confined to observatories or laboratories. They have spilled into philosophy, art, diplomacy, and faith. What does it mean to live in a universe that is shared? What responsibilities do we carry as the species that discovered the light? Are we to reach for it, to respond to it, to reframe our place in history because of it? The presence of the light invites not panic or paranoia, but humility. It reminds us that we are not the ceiling of consciousness. We are, perhaps, only one story among many. There is power in that idea. For too long, humanity has measured its greatness by comparison, against other species, other nations, other histories. But now, we are called to measure ourselves against the silence of deep time, against the patience of civilizations that may endure for thousands of years in places where no warmth exists except the warmth they create. To imagine such beings is to imagine resilience, vision, and a kind of hope we have yet to fully understand. They are not just builders, they are sustainers, and in their endurance, we may find a model for our own. This discovery does not diminish us, it deepens us. Just as Galileo's telescope once revealed moons orbiting Jupiter, shattering the illusion of a geocentric universe, so too does the James Webb Space Telescope remind us that we are part of something much larger. The light is not an ending, it is a beginning, a doorway, a single thread that once pulled may unravel centuries of assumptions and open us to the possibility of connection, real connection, not only across distances, but across kinds of existence, across ways of thinking, across futures. Perhaps the greatest lesson the light offers is this, that significance does not come from scale. A quiet glow, trillions of miles away, has altered the trajectory of our species, not through conquest, not through contact, but through presence. It teaches us that to endure, to illuminate, to simply be, in defiance of the cold and the dark is enough to change the universe, and that perhaps, in the end, is what binds us to whatever or whoever is out there. Not similarity, but the will to shine, to create meaning in the silence. So now, we wait, we listen, we look with clearer eyes and wider hearts. The cosmos, once a silent stage, may yet become a place of dialogue. Not all answers will come quickly or in ways we expect, but the first step has been taken. The first light has been seen. And somewhere, in the vastness between stars, we may no longer be strangers. We are watchers. We are thinkers. We are dreamers. And perhaps, just perhaps, we are no longer alone.